Hello again. This is the second part. Hopefully this will go a little quicker. I didn't really mean for that first one to take 25 minutes, but it's pretty important stuff, so I'm kind of glad that we're focused in on it. So we're going to talk about this probably when we come to class, the beginning of class. I just think it's easier for me to demonstrate how to do this than it is for me to show you right now. It'll be easier, and you can ask questions. We can confirm everybody knows how to do it. It's not vastly important that you know exactly how to do this right now. It's just kind of a convenient thing for you to have in your little mathematics arsenal. So we'll talk about this one in class. So this is like kind of a typical example question for this correspondence here. Don't tell me the domain, tell me the range, and tell me if it's a function. So when we have these, we call these ordered pairs. They look like coordinates maybe from like a graph or something. You could graph all these points if you wanted to, but the domain is always going to be all the first numbers in each pair. So for part A, we'd say the domain is -6, 1. There's 2 1s, so I have to write that twice, and then 4. So -6, 1, 4. For part B, the range is all the set of all the second numbers in the pairs. So that's 7, 4, -3, and -5. And the question then, part C, is this a function? And the answer is no. And the reason is we have this domain value -6 and it goes to 7. And that's fine. And there's no other -6s in here that are going to other numbers. So this one checks out. The problem comes with the 1s. Here we have a 1 in the domain and it matches up with 4. And for this third pair, we have a 1 in the domain, but this one matches up to -3. So the answer is no. 1 corresponds to both 4 and -3. And that makes it not a function. Since there's a 1 here and it goes to 4, and a 1 here and it goes to -3, it's not a function. Just so we can see this in this other method, if we write if we write the domain values and then the range values, -6, 1, and 4 are the domain values. Range values are 7, 4, -3, and -5. And -6 goes to 7, 1 goes to 4, and 1 goes to -3, and 4 goes to -5. The problem is this right here. Like the 1 is going to 2 different things. That makes it not a function. The rest of these, so this is the same kind of, these are the same questions. This one is not a function. And again, you see that 9 appears twice as the domain value and the range values are different. 9 corresponds to both -5 and 5. These are kind of the shortcut for problems that look like this is to just look at the domain values first. And if none of them repeat, then it's going to be a function. -2, 5, 0, 4. None of those repeat, so it's a function. -5, 0, and 6. None of those repeat, so it's a function. And remember, all I'm looking at is the domain values. Like the fact that 3 appears as the range value in every one doesn't affect whether or not it's a function. The only thing that does is whether or not the domain values repeat. And just so we can see this in this other format, those are the domain values for this problem. And the range values, the only one is 3. -5 goes to 3, 0 goes to 3, 6 goes to 3. This is kind of a boring function, but it is a function because there's no 2 arrows coming out of any domain value. So now last but not least, we can do these with pictures. This is just identifying the domain. And here the domain, like we said before, when we see the word, what is the domain of F, you should be thinking to yourself, X values. What are the X values that are used in this picture? And for here, for the range, you want to say, what are the Y values? So the X's looks like they start at 0 like the smallest x that's used to draw this function. Let's think about it this way. This point, which is the leftmost point, is the point 0, 1. And this rightmost point is the point 4, -2, probably. So the smallest x that's used is 0, and the biggest x that's used is 4. So I would say for A, the domain is all the x's between 0 and 4. There's a bunch of ways to write that. We're going to talk about it next time. One way you can do is you can say, boy, I don't know what that's supposed to be. You can say 0 is less than x is less than 4. Less than or equal to. This means like all the x's between 0 and 4. Again, we'll talk about the specifics of this later. The other way to write that is in what we call interval notation. And again, don't be like, I don't know how to do that and freak out. Just understand this means all the x's between 0 and 4. And for B, for the range, I want to know what's the smallest y value and what's the biggest y value. What are all the y values that are used? Well, it looks like the biggest y is up here, and that's 1. But like you don't want to look here for the smallest y value because this is -2, but you can see that all these ones are smaller than -2. So I'm thinking about the range, instead of talking about the farthest left and the farthest right, like I did for the domain, I want to talk about the farthest down and the farthest up. So here, the farthest down value is -3, it looks like. And the biggest one, it looks like it's 1. And I'm going to put a y in there this time. And if I was going to write this in interval notation, which again, you don't know how to do, maybe you do, but we haven't learned it yet. If you do know how to do it, it's from previous classes or something. This is from -3 to 1. So we can find domain and range from graphs just by looking at the picture and like reading the numbers off the graph. This one will be here. We'll talk about the domain and range from graphs a little more later, just so that you guys, I don't want you to be like, I don't know how to do it from a graph. It's okay. Here's another example. Okay, so for domain, remember, x values, y values for the range. So the smallest x that's used, look all the way to the left on the graph. It looks like it's -1. And then the biggest x looks like it's 5. So I put an x in there to indicate I'm talking about the x's. The smallest x is -1, the biggest x is 5. And for the range, I want the smallest y, which means the bottom of the graph. And that looks like it's here, which is probably -1. And then the biggest y up at the top here, it looks like it's 3. So again, I'm going to write this just so that you guys see it once before we talk about specifically next time. But this is called inequality notation because there's inequalities in it. This is called interval notation. So, but those are the examples. Hopefully that made some sense to you. You followed along with the notes, and talk about this a little more in class. Any questions you have, please note them. Thanks.